Hello, geometry students. For Mr. Fry, I am going to give you the accommodations, interventions, clarifications for quiz 4.1. This is due on the 7th, which is tomorrow. It's the 6th right now. So hopefully this helps. Let me go through and read this. We are classifying and solving for sides and angles and triangles. Directions: if G is the midpoint of AB, classify each triangle by its angles and sides. So this G right here is the midpoint of AB. So you should know that this is also going to equal this here. So this is also going to be, a 6 here if this is the midpoint. All right. So they want to go with the triangle, and I'm going to set this up where I'm going to use here are your choices for angles. Regarding the angles, you're going to either have acute, obtuse, or scalene. And then for your sides, you're going to have either and I'm going to abbreviate, your equilateral, your isosceles, or you're going to have, let's see, acute, obtuse. Oh, you're going to have your scalene over here. I put scalene in the wrong spot. Sorry about that. Scalene. This is going to be your right. I meant to put right if it's a right angle, okay? So your angle choices for each of these triangles are going to be, it's either acute, obtuse, or right. And regarding the sides of the triangles, it's either going to be equilateral, isosceles, or scalene, all right? So remember, acute means that all of the angles are less than 90. Obtuse, you have one angle that's greater than 90. And right, you have a right angle. You have a 90-degree angle in that triangle. Regarding the sides, if the triangle has all the same side measurements, that's going to be equilateral. If it has just two sides that are of the same size, that's going to be isosceles. And then if they're all different lengths, that's a scalene. All right? Hopefully you have your notes with you while you're taking this. CFE, and pause this as needed because I got to kind of rip through this now. Probably be in 2 videos because it takes too long to download or upload, a whole long video. So this will be the first half. So CFE, triangle CFE, let's take a look at CFE. CFE down here, CFE. Regarding the angles, if this is a 90, that means this is a 90 here also, okay? So would that be acute, obtuse, or right? And then regarding the sides, this is 2, this is 5, and this would be some other measurements. So they have all different measurements on the sides. So is that equilateral, isosceles, or scalene? For number 2, BEC. BEC. Okay. BEC, let's see. This is 6 and this is 2. So 6 plus 2 is 8. This side is 8 also. Okay. So I'm looking at the sides right now. So just 2 8s here and a 5. So regarding the sides, is that equilateral, isosceles, or scalene? And let me take one step back and talk about the angles. The angles here, notice that they all look, this angle here, angle E, angle B, and angle C, they all look less than 90. So would that be acute, obtuse, or right? And then, once again, the sides, you have 6 plus 2. Where do I get 6? Remember, 6, anything with a line is a measurement of 6. Okay, so 6 plus 2 is 8. This is 8. So they have 2 sides that are the same. So is that equilateral, isosceles, or scalene for BEC? For number 3, BFG. B, F, and G. Notice the angles are all less than 90. So is that acute, obtuse, or right? And then the sides, all the sides are the same. So is that equilateral, isosceles, or scalene? And then lastly, GAF. So GAF, this one down here, notice that this angle appears to be greater than 90. So is that acute, obtuse, or right? And then for the sides, notice that it has two sides that are going to be the same measurement. So is that equilateral, isosceles, or scalene? Take a look at number 5. For number 5, and you're probably going to have to pause this and work this stuff out. If W with the coordinates -10, 4, and X with the coordinates -3, -1, and Y with the coordinates -5, 11, classify WXY by its sides and show all work to justify your answer. You're going to have to use the distance formula. And the distance formula, in order to figure out WX, the distance between WX, you're just going to have to take those X values and the Y values, and I just listed them in order. So WX, so W and X, this becomes my X1, Y1, X2, Y2. So my X2s, Y1s, all that I have plugged in here for you. And you're going to have to take the square root of all of this. And I noticed that you could plug this into your calculator the way I have it written, with the double parentheses and all. You could plug that into your calculator and it will give you the answer, doing the square root. So that would give you WX, that would give you XY, that would give you WY. If you have a different way of doing that, that's fine. You could do it one step at a time and show your work. You at least have to show that you've plugged in these X and Y values. Remember, when you're these are all subtracting. When you're subtracting a negative, it becomes positive. So you might be asking yourself, how did Mr. Hunt get a positive there? It's a negative coordinate. Well, remember, subtracting a negative is going to be a positive. Okay, so that's all for number 5. For number 6, find all the missing angles. So for number 1, what you're going to have to do for number 1, you remember the sum of all the interior angles on a triangle is 180. So you're going to take 180 and subtract 72 and 57 to figure out what's left, which would be angle 1. When you're looking at angle 2, all you have to do, this is 90. So take 90 minus 72, and that will give you what's left over, which is angle 2. For angle 3, this is a straight line, so you're going to have to take 180 minus 57. That will give you what's left over, which is angle 3. Now that you know angle 2 and angle 3, you'll have to take 180 minus angle 2 minus angle 3, and that will give you angle 4. Okay, which again, you may have to rewind that, listen to that again, because I'm giving you a lot of clarification and help there. Number 7, if I want to figure out what angle 1 is, I'm going to take 180 minus 129. That will give me the measure of angle 1. If I want to figure out measure of angle 2, I'm going to take 180 minus what I just figured out for angle 1 minus 95. What's left over, hit equals, that will give you angle 2 measurement. Angle 3 measurement is going to be 95. I'll give you that one. It is a vertical angle here. When you're looking for angle 4, you're going to take 180 minus 95 minus 47. What's left over will give you the measure of angle 4. Angle 5 is going to be, and there's another gimme, it's a vertical angle, so it's going to be the same as this angle, so 47. And before I get to angle 6, I want to figure out angle 7. I got to take 180, since this is a straight line, 180 minus 121, that will give me angle 7. So angle 7 is 180 minus 121. Once you know angle 7, and you already know angle 5, you're going to take 180 minus angle 5, minus the measure of angle 7, and that will give you angle 6. So you go back and get angle 6, whatever that equals. Okay, for number 8 and 9, I have it written out here. You're solving for x. This angle, and this angle equal these expressions. All you have to do is add all of these expressions to equal 180. Combine your like terms, isolate the variable x. You'll be solving for x. for number 9. This one's a little different because, okay, you have the other side of this, which is 180 minus this. This angle right here is 180 minus whatever this is. So I have to put it in parentheses. So 180 minus this value in parentheses is going to equal this angle, plus this angle, plus this angle is going to equal 180. Go ahead and work this out. Use the distributive property here. Combine your like terms, solve for x, and you'll get your answer there. Okay, look for the second page on the second video.